Greetings. I'm Dr. Jason Ozuko from the Psychology Department at SUNY Geneseo, and welcome to the next video in my online PsychoPy course. Today we're going to be continuing to build off of the memory experiment we saw in the last video, but we're going to be trying to do some more advanced things with our experiment. For instance, in our last video, we set up a stimulus list of words. However, our list was actually very rigid in so much as the same 6 words would always be the study items for every subject that ran in our experiment. What if we would like to randomly shuffle words from a stimulus set such that different subjects got different words in their study set and test set? So we wanted to better randomize our stimuli. So how do we get away from this rigid arrangement of stimuli such that we can have a random set of 6 words be the study words for any particular subject, and another random 3 items be added into the test phase? Because no matter how many times you run this experiment, these words will always be the study words for every subject in our study. So how do we actually break this? And the way we do this is by introducing some custom code. So rather than letting PsychoPy load in our Excel sheet for us and assign our stimuli, we're actually going to be loading stimuli in ourselves, and we're going to be handling all the shuffling and assignment of items ourselves as well. So in order to do this, I'm going to introduce the idea of having a loader loop. So I'm going to create a new routine, and I will call this the word loader, and I'm going to insert this at the very beginning of my experiment, even before the welcome screen. And around this word loader, I'm going to insert a loop, and I'm going to call it the word loading loop. And I will change selection to sequential, and I'm going to turn off trials, and I'm going to set it to 1 repetition. Now, what I want to have happen in this loop is, first of all, nothing is going to be shown to subjects. So I'm not going to insert any text component, no image component, there'll be no keyboard component. There's only going to be code. And what I would like to have happen in this loop is I want this loop to load all the possible words in my experiment. So I had my test word Excel sheet previously made, and I had my 6 items that were old and 6 that were new. I'm actually going to erase the old new column, and I'm just going to leave this now as a set of 9 words. And this is the Excel sheet that I'm going to select for my word loading loop. Now, you could have a list, you could call it like the word pool or the stimulus set, and we could have many more words. And in fact, I'll add that in just a moment, but let's just start with our original 9. So what's going to happen in our experiment so far? Well, our word loader is going to be iterated through 9 times, and we're going to grab every single word out of our word list. We could, by the way, leave this as random if we wanted. I'm going to have it as sequential and show you how to shuffle items yourself, but there are circumstances where you might want it to be random or sequential, but suffice to say, you don't need to worry about PsychoPy shuffling your list, because we'll be doing it ourselves. So I'll just have it load in everything sequentially. All right, now in my word loader, I'm going to insert a bit of code. And this will be my word loading code. And at the beginning of every routine, so basically every single time this loop cycles, so every time it loads in a new word, I want it to add the stim word to a list of mine. So I'm going to have a list called word list. And word list is going to be empty. And I actually have to move this. So this is me defining a list and starting it as having no entries. I can't have this occur every single loop. Otherwise, every single time we loop through our list, we'll clear our own list and just add 1 word. So I'm going to have this occur at the beginning of the experiment. So at the beginning of the experiment, I'm creating a variable called word list, and it's empty. Now, each time our word loading loop cycles, we append onto the end of word list the stimulus word that we're loading. And so what this will do is ultimately give us a list of our 9 words that we're loading. And we can see this in action using a handy print statement. So I'm going to just print out oops, not stim add, stim word. I'm going to print out the word that we appended to our list. And if you recall, when we looked at how to code in our Stroop experiment, I'm assuming you guys have watched that video at this point. If you haven't, you'll definitely want to go back and look at that. But I'm going to turn off full screen mode just so we can get a better view of our developer console as we go, so we can see our print statements and we'll see any errors that we come across as we code our experiment. So we're cycling through, loading our words. And we get our welcome message. I'm just going to cancel out of that. And I want to see my runner. And if you notice here in the output, here are the words that we loaded. And these are our 9 words. And notice that they're being loaded in order. Now, I should note, too, that there are multiple ways of reading an Excel sheet in Python. In some of my older videos, I actually recommended using a library called XLRD to read things in manually. However, that's not going to work if you try and run your experiment online. So this technique I'm showing you here today is a more modern way of doing it, and it will allow your experiment to work both offline and online if you decide to run it on Pavlovia. So our words are being loaded in. This is good. I'm going to insert one more routine, and I will call it our word shuffler. Or you could call it like the stimulus arranger or something like that. But it's basically another routine where after all the words have been loaded in, I can now start to do things with my word list. So I'm going to insert code again, and I will say, this is the shuffle word code. Okay, so when this routine begins, think about what we've got. We've got a word underscore list variable that contains all of our 9 words, but in order. So the first thing I want to do is I want to shuffle that list. So I'm going to use the command in Python or in PsychoPy called shuffle. And again, we looked at this in my Stroop video. And what this is going to do is randomly arrange the 9 words that we have loaded in. So first steps first is to shuffle that list, and we did so. The next thing I would like to do is I want to assign the first 6 words to be old items and the next 3 words to be new items. So I need a list called old new. And what I'm going to do, and there's many ways to do this, is I'm going to set the first 6 items to be old. I think that's 6. And the next 3 to be new. So this is sort of the brute force way of doing it. 1, 2, 3, 4, 5, 6. And this will create a list where the first 6 items are old and the next 3 are new. Now, this is not really too practical when you are dealing with actually big stimulus sets. Say you have like 90 words and you need to arrange them. Maybe in multiple, in terms of, into multiple different category types. So not just old and new. So rather than sort of manually just adding an old item for each entry that we want, I'm going to let the computer use a loop for us and iterate through. So in PsychoPy and all programming languages, there's a thing called a for loop. And what we've typed out here is code that will make this code cycle through 6 times. So for I in range 6. This is basically saying cycle through, and for each cycle of this for loop, I will start at 0, then be equal to 1, then 2, then 3, then 4, then 5, and then it will end. And that will ultimately give us 6 entries. And so if on each cycle of this for loop, we execute this code, then we will be adding 6 old entries into our old new list. You can probably guess what I'm going to put here, and that's a 3. So that we end up with 3 more entries in our old new list, and that's for new items. So this code will take the word list, it will shuffle it, and it will provide us with 6 old items and 6 new items. So now, in our study trial here, what we can do is, remember, our study trial is trying to load stim word. Why don't we set this stim word variable ourselves to be equal to an item from the word list on each cycle? Remember, the first 6 items in our word list are old. So what we can do is, on the first iteration of our study loop, we can look at word list 0, and that will give us our first old word. On the next iteration, we can look at word list 1, and then we can look at word list 2, and then 3, 4, 5. So by looking at the first 6 word list entries, we can grab our old words. So in order to do this, what we need is a variable here. We need a counter. So maybe a variable like current word. And we set that equal to 0. And then what we would do on our study trial is we would try and show word list and the entry for current word 0. Then when we loop to the next item, we just add 1 to this so that we're now on current word 1, and this will now show the next word. Then as we loop again to the next study item, we add 1 again, and now we'll be in item 2, and so on. So what we need is a variable like current word. So why don't we create a variable here, and we'll say current word is equal to 0. And what we'll do in our study trial is we'll insert a little bit of code, and we'll say, hey, at the end of the routine, current word is equal to current word plus 1. Or another way to write that out is current word is plus equal to 1. That means current word is equal to itself plus 1. So we'll call this the study counter. And I'll move this to the top. Now, we said here that we want to show word list, and we want to show word list or open brackets current word. So we've got in here current word. So again, think about what we're doing. We're accessing our word list. We're starting at item 0, and we're iterating through 1, 2, 3, 4, 5, and then at 6, we've ended. The one last change we'll have to make here is under study trials. Rather than having an Excel sheet, we're going to get rid of that. And rather than having selected rows, we're getting rid of that. So we still have trials. You can leave them as, loop type random, sequential. It doesn't matter anymore because PsychoPy is no longer randomizing items from an Excel sheet. So it doesn't matter what this is equal to. It won't make a difference. But number of reps, this is where we have to change this from 1. And we ultimately want this to be 6 because we have 6 items to show. If we left this as 1, then this entire loop would just cycle through once. The reason we could leave it at 1 before, and it would go through all the items in our study sheet, is we had an Excel sheet here, and the Excel sheet had 6 items. Or we were telling it to only select 6 items from the Excel sheet. So the loop would cycle through the Excel sheet once, grabbing each item once, giving you 6 trials. But when there's no longer an Excel sheet, and now you're manually determining variables with code, you actually need to determine the number of repetitions, which should be 6. And we can do one better than hard coding it, because let's say that later on in the future, we revise our code, and rather than loading in 6 items, we want to have 20 items. Right? So if that were the case, we'd have to go and find all the references to 6 and change that. But why don't we just have a variable called numStudy, which is the number of study items. And let's just put that in for both adding the old tags and then in terms of the number of repetitions for our study loop. So now in our experiment, this study phase will loop through 6 times, and on each cycle, our code is going to be counting up this counter, this current word counter, and we're going to be showing the word from the word list for the current word that we're on. Okay, let's give this a quick run and see what happens so far in our experiment. I'm going to say, okay, welcome to our experiment. So this time, button, green, country, Android, Cliff, Hill. We're in our study phase. I'm going to rerun this experiment and see if we can spot a different item that's in our study phase. We only have 9 items in total in our stimulus set, but we should still, even with that few items, not see identical study phases. So think circle or laptop was not in the set before. And we could check our data files if we want. But suffice to say that right now, we are randomly selecting items from our list, and they are ending up randomly assigned in our study trial. Now, let's think about how we want to arrange our test trial. You might be inclined to say, okay, well, let's just do what we did with the study trial. Let's get rid of the conditions. Let's set this to num test, which we will assign in our earlier code. Let's go into our test trial, and let's add some code at the end of our routine. And let's say current test word plus equal to 1. And let's say that we're going to present word list current test word. And then all we have to do is come back in here and define that we have 9 test items. So rather than having a 3 here, we could have number of test minus number of study, which will be 3. It'll be the number of extra test items we have over and above our study items. That will be how many new tags are added to our word list. And we need current test word. So you might think, okay, everything's going to work now. That's great. However, we have one little problem. Think about what is in our word list. The first 6 words are old items. The next 3 words are new. In our study phase, because we had randomly shuffled our word list, in our study phase, we could load words out of the word list one at a time in order, and we could present those to subjects, and that would be the 6 study items in a random order. However, if in the test phase, we simply move through the first 6 items again, we're going to be showing those same 6 study items in the same order at test. And the 3 new items will all appear as items 7, 8, and 9. They'll always appear at the end of the list. So we need some way to reshuffle our word list for our test phase. And so you may say, okay, well, given this problem, why don't we just use shuffle? How about just before the test phase, we shuffle the word list? Well, we can't do that, because if we shuffle the word list, our old new flags don't match up to the words anymore, right? The first 6 old new flags are linked with the first 6 words. So the first word is old, the second word is old, the third, the fourth, the fifth, and the sixth are old, and then items 7, 8, and 9 are new. If we shuffle the words into a new order, then maybe the 9th item now is the first item. And so that will be the first item shown at test, but that isn't the item that that we're identifying as old. So we basically have a problem. What we would like to do is take the old and the new flags and combine them with the word list and shuffle everything together. And so there's a couple of ways you can do this, but the way I'm going to show you today is, rather than trying to directly shuffle the word and the tags list separately, is to create what's called an order list and to shuffle that. So this time, we're going to iterate through the numbers 0 through 9. So we're going to have another for loop down here. Oops, and this should be a colon. And we're actually going to create a list called order. And on each cycle of this loop, we're going to append the value I to order. So order's first going to come out like this. Order will be equal to that. So if I were to grab order 0, I would get 0. That's this item. If I were to grab order 1, I would get 1. If I were to grab order 2, I would get 2, and so on. So right now, the order list is in order. But what happens if I shuffle this list? Well, now maybe order is equal to something like this. So now the order list is in a funky order. So now if I were to access order 0, I would get 1. If I were to access order 1, at the next item, I would get 3. And then I would get 4, then 6, then 8, then 7, then 0, then 2, then 5. This looks like a random order of stimuli. So in the test phase, rather than accessing word list 0, if I want the first item of my new randomized order for my test list, I'm going to get word list from order 0. Because this number could be anything, right? Because these numbers are in a random order. So order 0 could be any number, but it will be one number from 0 to 8. And I can count up through my order list and access all my different words in a unique order. And the thing about doing this is the reason we're doing it is because now I can access the corresponding old new status. So if I had just shuffled my word list and the old new status would have become uncoupled. But because I haven't rearranged my word list or my old new status list, and I've just created an order list that I've randomized, I can randomize that order list as many times as I want, and as long as I refer to my word list and my tag list using my order list, I can be sure that I'm getting the items that link up to one another. So we don't know what item order 0 is. It could be 1, it could be 5, it could be 9 or 8, it could be 7, it could be anything. But whatever it's equal to, if I grab word list order 0 and old new order 0, I'm getting the word and the old new status that correspond to each other. So that's why I'm doing this. So let me get rid of, so some of this code I was writing here to just demonstrate to you guys. So we have a counter called current test word. We are setting that to be 0. That is going to count up 1, 2, 3, 4, 5, 6, 7, 8 as we go through our test list. That is true. However, we're not going to directly refer to word list items or old new status. Instead, we'll refer to the order numbers of the word list item and the order numbers of the old new status. So this is going to create my order list and shuffle it. By the way, I'm not commenting my code in this video here today, but I'll add some comments before we're done. It is really good to be diligent about commenting on your code so that it's easy to read when you want to come back and see it later. So increment our test list counter. And what I'm going to do here is just change this. So rather than grabbing the word list of the current test word, it's the word list of the order of the current test word. And in my feedback, so now in our previous version of the experiment, old new is being pulled from the Excel sheet. Now we want to pull it from our current test word. But again, we can't just use the current test word itself. We have to use the order of the current test word. And this will successfully grab the old new status that corresponds to whatever word we happen to be seeing. And let's just check in here. Yep, here's another reference to old new. I'm going to change this. So let's add some comments to our code. This is log the yes, no variable. Go over here. This is our default item status. Item status sold. We can see what happens. This is else assume item status is new. And where we really need some comments are over here in our word shuffler. So this shuffles, or we'll, let's say, randomize the order of our word list. This here. Assign number of study test trials, create old, new statuses for our words. This sets our study and test counters to 0. Here, create an order list for our test phase. And shuffle the test phases order list. So the logic of what we did isn't too complicated, but there are a few steps to it. But with this little bit of code, what we are now doing is loading in our own stimulus pool, randomizing it. We're presenting the items at the study phase. We're presenting items in a new random order for the test phase, and we're logging everything nice and neat. Oh, and there is one error that we've got here in our code just before we run it. So right now, our test trial is presented, and we calculate our yes/no response. And at the end of presenting our test trial, we increment our test word counter. We actually don't want to do that yet because we still have a feedback screen to show. And if we increment our counter before we show our feedback, then our feedback starts referencing the current test word, and we've moved on to the next test word before we're done. So we don't want our current test counter to be incremented until the very end of our test trial. So that would be the end of our feedback here in this case. So with that one little change, we can now run our experiment, and we can see our new arrangement of items. So button, green, laptop, machine, Android, hill. Okay, let's see if we can do this. Hill was in the list. Button was. Green was. Machine, Android, laptop, I think were too. Cliff wasn't. Let's try and make a mistake. So I think machine was in the list. So, yep, we got mistake there. Laptop was in the list, but I'll say no. Also a mistake. And Android was in the list. I'll say yes, because I know that it was. Circle, let's say no. Pretty sure it wasn't. There we go. And country, let's just say yes. I'm pretty sure country wasn't. There we go. So we've made a couple of different kinds of errors. Our experiment ends. And now looking into our data sheet here, we can see that indeed, so there's the correct key that should have been pressed. There's what we pressed. We can see what kind of response we got. Notice, by the way, that nowhere is the word that we actually showed on the screen being logged. And we dealt with this in the previous video where I said any variable that you calculate yourself, you have to log. Otherwise, PsychoPy is not going to log. So why don't we actually also log the word that is being seen on each trial. So stim_word is equal to word list order of current test word. And let's copy this and make sure we're also logging things during the study phase. So the beginning of the study phase routine, we want to log the current word. That's the counter that we're using, current word. And we'll log it under the same variable. We could have study underscore word here and test underscore word in the test phase if we wanted a different label. And let's click run. So our study phase goes by. I'm just going to answer very quickly and randomly here in the test just so we can get to some data. And with the experiment over, let's go ahead and open up our latest data sheet. And now we'll find a stim_word column with the different words. Now, the one other thing that we should take a quick look at is what happens if your stimulus set gets bigger. And again, this is where you can have a really big stimulus pool that you're drawing from, and every subject will just get different words. So we can add like alien. So I'm just trying to add a bunch of random words. It's surprisingly difficult to come up with random words just on the spot. But there we go. We've now loaded in a list of, I guess, 18 words. I'll save this. The nice thing is that after you've gone ahead and coded things to load things from a file, there's really absolutely nothing you need to do to your code to draw from that larger pool and randomly assign some of those items to your subjects. So everything that we've already got here is going to work just as is right out of the box. So our stimulus loading loop is now going to go through 18 words rather than 9. But look at the rest of our code. We're going to shuffle the order of that list. The first 6 words, whatever they happen to be, will be our study set. The next 3 will be our test. In fact, we could double this if we want. We could just, with one line change, we could now have 6 test items rather than just 3. You know, we could change this to whatever we want. And as long as we have enough items in our stimulus pool, our experiment's going to work just as easily. So the nice thing about coding things up this way is it's a little tricky to set it up initially, but once you get it set up, things are very flexible and you can just change one parameter and you can double your test items. You could get rid of all your test items if you want by just having the same number of test and study items. So let's have this as 12 and let's go ahead and give this a run just so we can see. And again, every time we run this experiment, we're going to shuffle our big master stimulus set, and we're going to get a different set of study items and a different set of test items for our subjects. So this time around, pencil and island are new words that are in there. I'm not even going to go through the test again, but let's just run this, and we can see what our next study set is the second time that we run this. Having changed nothing in the code, again, it's all happening randomly within the code. So forest, bank, island is showing up again. Country's in this time. So you can see you'll get a different set every single time. Now, if we're going to run this on PsychoPy, you need to go to Pavlovia, new experiment. Make sure you select yourself as the owner, the folder you're running this from, the name your experiment. Create your experiment on Pavlovia. Go through the steps that we've seen before. Again, an error message like this, you just click OK, but it will still upload. We're committing 25 new files. Go through the same steps we've seen before where you verify your experiment is up, you put it into piloting mode, you run it. And so when you go to try to run your experiment online, this is one of the instances where there's a few incompatibilities with our code compared to what Pavlovia expects. And we've looked at how to fix this before, but just as a brief refresher, every instance of append has to be changed to push, and this experiment.addData has to be changed to psychojs.experiment.addData. So coming back to our code here, in the cases where we have an append statement, this has to be changed to push on the JavaScript side. And again, in our advanced first experiment video, we looked at doing this. So I'm not going to go through all the steps of fixing everything because we've covered that quite well. We also do have to have at the beginning of the experiment, we need to define shuffle for the JavaScript side. And I missed a push right over here. And then in terms of logging our data, you have to look through both the study and test phase. Every time we are using this experiment.addData, it should be psychojs experiment.addData. If you make all those changes, and then try to run online again, and now our experiment works. So yeah, just a couple of quick fixes to make your experiment Pavlovia compatible. Again, if all those fixes that I just made look unfamiliar to you, go back and check my previous videos where we cover putting things on Pavlovia a bit more slowly. But the code that I showed you here today was largely compatible, just needed the appends changed to push, needed this experiment.addData changed to psychojs.experiment.addData, and it needed the shuffle routine defined as var shuffle is equal to util.shuffle at the beginning of the experiment in some piece of code. And with that, your experiment works. So this has been our advanced look at loading and shuffling stimuli in PsychoPy. We have a couple more advanced loop videos coming up, so if this video has been useful to you today, keep an eye out for those. In the meantime, if you haven't subscribed to the channel already, please don't forget to do so. And if you are in need of some PsychoPy consulting or programming help with your experiments, I offer both consulting and programming services, the details of which can be found in the description down below. So if you do need help, don't hesitate to reach out. Other than that, I will catch you guys in the next one.